Alrighty, for this one, we're talking about 5-5 for our lesson, which is solving inequalities involving absolute value for Algebra 1. This is the L.3 IXL. This is not one that we formally assigned in class or anything for my students. However, it is going to help us take a look at this and further our understanding. In order to get going into this, we'll have to refresh ourselves on what it means to have that absolute value bracket or absolute value bars around one side of our inequality, or it works the same in an equation. Basically, whatever result you get once you simplify the inside of those as if they're parentheses, that value is going to become positive, whether it was negative at the beginning, it'll turn positive, or if it was positive, it's going to stay positive. It's not like a perpendicular line where it's an opposite reciprocal kind of situation where the sign flips. It's always going to go positive or stay positive. So it's not necessarily a flip, more so than just always one certain type of value. That being said, when we go to solve this to take into account both cases, one where the value was negative and flipped, and then one where it was positive and stayed positive, each time we're solving something like this, we're going to have multiple cases, or basically multiple variations of this problem that we're going to work through. So I'm going to put case 1 and case 2 to show the different instances we could have had. So we're going to solve this pretty much as is for case 1. We're going to just drop the absolute value bars, and we're going to have b plus 3 less than 6. If I solve that by taking away 3 from both sides, I end up with values or numbers less than 3. That part's pretty self-explanatory. However, with case 2, everything's going to be the same except I'm going to distribute a -1, or at least multiply everything by -1 on the left-hand side to take into account like that flip that we talked about before. This should be a 6, not a b at the end here. Oops. Let's rewrite that. Okay, so you could distribute and solve there. However, it'll create more steps than are needed. I'll show the faster way, but you can do either if you're more comfortable with distributing. Right off the bat, you could simply divide both sides by -1. If you did that, it would leave just b plus 3. And then what I would have on the other side is 6 divided by -1, which would give me a -6. And then I have to remember that in the process of solving this, I divided by a negative, so that inequality symbol changes direction. From here, I'm going to subtract 3 just like I did in case 1. However, this time it's going to become more negative, meaning I'm going to get -9. So when I read this, I want numbers that are less than 3, but also greater than -9. Anywhere in that range would simplify or would work for this absolute value inequality. As kind of a hint or trick moving forward, anytime we would have used and as like our separator in our compound inequality before, for this IXL, we're going to write it like it has right there. So I want the values to be bigger than -9, but less than 3. So how I would write that, -9, and then the inequality symbol to where it's opening up towards x, kind of like the underlined version right there. Another inequality symbol, same thing. This time it's opening up towards the next number. In this case, it's going to be a 3. So hit submit. Oh, what did they not like? How I did it. Oh, I got to put... Okay, apparently you got to be cautious with the spaces in here. Oh, okay, never mind. I used x. That was a silly mistake by me. Be careful there. Don't do what I just did. Use the correct variable. Okay, we showed it solved properly then. It was just, I've made it x instead of b. All right. Let's take a look at another one then. Since we've already technically answered one, just got to be careful with the variable. Let's skip ahead a little bit. Let's try something like this. So case 1, I'm just going to put C1, and case 2, I'm just going to put C2. I would have -3 times R less than or equal to 12. The other one, I'm going to have a -1 times everything. Oh, I'm running out of space. Okay. So for case 1, I would divide both sides by -3. That would leave me with R. Because I'm dividing by a negative, that inequality symbol is going to flip. And then I'm going to have 12 divided by -3 is -4. So numbers that are greater than or equal to -4. For the second case, I could do what I did last time and divide by -1 right off the bat. Because I'm dividing by negative, that's going to flip. And then I'd get -12. However, I'm just going to divide by a -3 now, meaning it's going to flip again back to where it was. And then this is going to flip to a +4. So you just got to be real careful with the signs and what way the inequality symbol is facing. If you remember from like elementary school when you were probably first taught this, usually most teachers call it like an alligator mouth, like it opens up and eats the bigger number. Got to make sure that's facing the right way. So I want numbers that are bigger than -4, but also less than or equal to 4. I'm going to remember to use R this time. So I'm going to put -4. I'll have to use the button here to get my value, or to get my symbol, R. Same symbol again, and then +4. Awesome, there we go. I promised I was doing it right the first time. I just flipped the variable. We'll talk about this one in a second. Something that we didn't see on IXL that we probably would get mentioned in class, but not on here, is if you've noticed, we've yet to have a set of absolute value bars, maybe like the last one, where we wrote out less than and then some negative number. You'll never be able to get a solution when you only have on the left-hand side or on one side the absolute value stuff, and then less than, and then a negative number, or just a negative number in general for most of it, because whatever you get in here is going to turn positive at the end. Any positive number is automatically going to be greater than a negative. So if I have less than a negative, I'm never going to get a solution there. So just something that probably won't occur in this IXL. Okay, back to the problem at hand. Notice this one. There's a -6 outside first. I want to move anything that's not in the absolute value brackets over to the other side first before I start into my cases. So that means I'm going to add 6 to both sides. So 2 plus 6 is 8, giving me something like this. Now that on one side I have just the absolute value bars, now I can start my cases. That's something that's been a common error in the past for some of my students. They try to go straight to those cases. That's the thing they remember. But you got to move everything that's not in the bars over first. That being said, one of my cases, since there's nothing else besides the V on the inside, it's going to look just like that. The other one would be -1V, meaning I'm going to have to divide both sides by -1, causing the symbol to flip, causing that to be -8. So when I write this out, I'm going to want numbers bigger than or equal to -8, also less than or equal to 8. -8 is my smaller one, so I'm going to put it first. I want the symbol with the line underneath. I'm using a V this time, same symbol, and then 8. Awesome. Okay. Let's go ahead and take a look at this one. I think this is going to give us something a little bit different. Let's clear this off. We have greater than or equal to for our starting symbol. I have nothing on the outside of the absolute value, so I can start into my cases, case 1 and case 2. I'm going to have negative 4 p greater than or equal to 8. I'm going to have negative 1 times negative 4p, and then everything the same. For case 1, dividing by negative 4 is going to flip my symbol, and it'll give me a negative 2, so I want values less than negative 2 for that one. For this one, if I divide by a negative 1 first, that's going to be what I have left over on the left. It'll flip my symbol and give me negative 8. However, when I divide by negative 4 again, in case 2, it's going to flip the, like I said before, alligator mouth back to where it was, since we're flipping again. Negative divided by a negative is going to be a positive. That's going to give me a 2. This time, if we think about what we have here, numbers less than negative 2, numbers greater than 2, our arrows are actually going to be pointing away from each other if we were to put this on a number line. So we're going to use this OR answer that we haven't used yet. So when I type this in, I'm guessing IXL is going to want the smaller one first, like the less than first. So I'm going to put P less than or equal to negative 2. Or I think you can type that in as well, but I'm just going to be safe. P greater than or equal to 2. So you got to be really careful with what way your symbols are opening up in this IXL. Super. Okay, I'll jump ahead and see if there's anything different. If not, we'll wrap up right here. We'll see what we have at a higher SMART score. Okay, that looks like something we've covered, and looks like something we've covered. Okay, so a couple takeaways before we wrap up. If they ever want you to get less than a negative when it's just the absolute value by itself, you're not going to have an answer. Usually when we have less than to start out with, our answer is going to look like this one. Usually when it's greater than, it's going to be the OR option. Be sure to, if there's something with the absolute values but not inside it, move that all to the other side before you start your cases. And then if you would prefer to use distribution instead of the division of negative 1 that I kept doing, that's going to work too. It'll just add one step for you. Okay, if you have questions that I did not answer here, feel free to leave a comment. If it did help, feel free to leave a like and a reminder to subscribe. All right, we'll see you guys.